Hi, everyone. Thank you for being here. Black Fridays are crazy. When I moved to the US, that's one of the first things I noticed, that Black Fridays can be pretty intense, and no company wants to be in a position where their infrastructure crashes and they get rolled online in addition to lost revenue. So I think it's a fascinating talk. We have with us today is Sanjoy Mukherjee and Shrikant Bulusu, who will be talking about how JCPenney successfully transformed their business into being able to scale up for Black Friday as well as 100,000 deployments a year. So this is going to be exciting, and I hope that you guys are in for a very interesting session. The floor is yours.
Thank you. Thank you all for joining. Good afternoon. Yeah, today we'd like to talk about digital transformation at JCPenney, how we onboarded our services to cloud, containers, and an open source-based platform. I'm Shrikant Bulusu, engineering leader at JCPenney.
I'm Sanjoy Mukherjee, distinguished engineer at JCPenney.
So how many of you have watched an Indian movie, Rise of Ants? Cool, quite a few of you. So our journey so far has been like a typical Indian movie, like boy meets girl, they fall in love, start going out, and then there's a bad villain who enters the movie. The hero fights the villain and comes out victorious at the end. A brief introduction about JCPenney. It was started in 1902 by Mr. James Cash Penney when he launched a store in Wyoming. We have over 100 plus years of history. We have over 860 stores in 48 states and Puerto Rico. We went public in 1929, and we started our digital journey in 1994. That's when we launched our .com site. So retail from the beginning of its time has been an evolving industry, right? And JCPenney all throughout its time, like over 100 years, has adapted to the customer needs. And the dawn of the new century saw the emergence of digital. We saw more and more customers shopping on our e-commerce platform. And lately we see mobile adoption. So we saw this as a great opportunity. We wanted to provide our customers a seamless experience across all the channels, right? Our store, our desktop, mobile, even the tablet. So, and we wanted our customers to have an ability to walk into one channel, browse, and check out in the other channel, or vice versa. So to make this happen, we started off by looking at our challenges in process as well as technology. These are some of the technology challenges that we identified. We were running a monolithic stack where we were bundling all the services into one big ER file, and we were releasing in a big bang manner, which was pretty scary. And we also noticed the teams were working in silos, and the projects were run in a waterfall model. This hampered speed and also led to higher costs. The one more point that we wanted to call out is we were running a vendor-based platform, which constricted us to a monolith architecture.
So the monolith architecture and the deployment also caused operational challenges. As for example, like when we roll out features, there might be one feature that is not working to our need, but we have to roll back the entire release, and there might be other features that may also roll back, and it will impact our customer experience. We also had a lot of changes going in every release, so trying to tie back a production issue to a set of changes was also challenging. So what we had to do is to increase our testing cycle so that we can catch all the problems up front, and that impacted our time to market. Since we are deploying this monolith in our data center, we had to, at the beginning of our yearly cycle, we had to go back and project how much is our infrastructure need, and so that our infrastructure team can go procure the hardware and make it ready for us, especially for our peak period. And we couldn't scale up and down based on the demand. So that hampered us. We had to spend a lot of money in capital expenditures. And finally, Shrikant mentioned that we used a proprietary platform, a commercially available platform, which forced us to use an RDBMS. And since we had a distributed data center, like in a couple of geographic locations, it was hard to keep the data in sync between these data centers. So we had to have special software, special processes to make sure that the data is consistent across our data centers, and if there is a problem, we have to remediate that without impacting our customers. All these impacted our ability to deliver in time.
So we came up with a simple goal, that is to create a platform to boost productivity and to improve time to market. We got to work, we came up with some key decisions. One of them is we wanted to be lean, agile, and nimble. We wanted to collect our customers' feedback as many times as possible and as early in the cycle as possible, right? And iterate based on the customer's feedback. If the feedback was positive, we wanted to put all energy behind it and get the product out there in a sooner manner. And if the feedback was not so great, we wanted to fail fast. The other decision is adoption of microservices. We noticed it could help us in twofold. One, it could decouple the services. Second, it could eliminate big bang releases. The other one is portable services. The services that we were building, we wanted them to be portable, be able to host in cloud, data center, or any other infrastructure that we have available. This was also an effort of future-proofing our work. And we also wanted to build once and run anywhere. This takes us back to a common problem. We have services run great in the developer's laptop. When it gets deployed to a higher environment, we start seeing issues. We wanted to address this problem, and we noticed that Docker was readily, just adopting Docker could solve this problem, so we were more than happy to adopt that and package our services as well as the dependencies into a Docker image. The other key decision is adoption of cloud. So JCPenney's core business is selling merchandise to our customers, so we wanted to focus all our energy on the core business. And the enablers like infrastructure, we were more than happy to leverage and work with any partner as long as they met our needs. And we realized there were multiple cloud providers who were doing a great job, so we decided to partner with one. And we invested heavily in automation. So we automated all the repeated tasks, which enabled us to move faster and eliminate any human error. The other key decision was adoption of open source technologies. So we noticed there were others who have been through this journey. They were able to transform their stack to microservices, and they have written blogs about it, and they have open sourced their tools and technologies. So we were more than happy to leverage what the community provided, and we had to customize some of these tools to meet our needs, which we plan on open sourcing in future.
Right. One of the decisions that led us to adopt open source and invest in our automation is because we want to run this new application that we are going to build, these microservices on an immutable infrastructure. And the reason we wanted to do that is because we wanted to have a very seamless experience for our development teams to run in a lower environment or in a higher environment. And we want to keep that infrastructure, the configuration drift between infrastructure to be minimal and without any manual intervention. So we wanted to create an infrastructure as a code. We want to check in our scripts, and so that we can create the infrastructure on demand. We can scale it on demand. We can scale it up or scale it down based on how our services are doing. And since we moved away from the proprietary framework and adopt open source, we were able to adopt, or we are able to offer polyglot persistence for our application teams. No longer they are sort of constrained to use an RDBMS backend. They're free to choose a database technology that will help them deliver services in their respective domain. And also, finally, the other issue we have is that, remember, we had the replication problem. So we wanted to adopt some NoSQL databases that has an inbuilt replication across geographic region, and to solve our data consistency issues that we faced earlier.
So we started off with a POC in 2016. We made some technology choices. As you could see, we adopted Docker. It enabled us to abide by two of the principles that we discussed earlier. We are able to build portable services, and it also enables us to build once and run anywhere. For our orchestration needs, we chose Docker Swarm. It supported Docker API out of the box, and it was supporting Docker Compose, which we were using in our local, and also we found it to be the easiest to use. For our cloud platform, we leveraged some of the components from Netflix OSS stack. We use Zool as our gateway. We use Eureka for service discovery and registry. We were using Ribbon for client-side load balancing, and we also use Hystrix, to prevent cascading failures and to implement fallbacks. For the development frameworks, we chose Spring Cloud and React.js, and we were running all these services in AWS. So to our journey. So we started off with the POC, and we identified two services that we wanted to onboard to the new platform that we were building. One, a browse service, second, a transactional service. Right, so the dev teams got to work. They were building these new services while the platform and the DevOps team were working on the infrastructure automation piece like CI/CD and building the environments, and do it in a repeated fashion. It all came together in 2 months, and we were able to launch these services on the new cloud container and open source platform. And using our API gateway, we started throttling some of the traffic to the new services. The feedback was fairly positive, and we got to a point where we had 100% of the traffic for these two services flowing through the new platform. This was a huge win, and it got a great response from our dev community. Now these two services can release at their own cadence without having to be a part of the release train or be a part of the big bang release. So that resonated across the entire dev community, and more service owners wanted to onboard their services to the new cloud platform. So we were more than happy. We started working with our service owners. We came up with the roadmap to onboard all the services that are required for an e-commerce business to function, and we got to work. We got to a point where we had 30 services onboarded in about 6 months. So everything was going along great. We got a good plan. We were on track. We had the business as well as our technology leaders sign off on the plan until we hit a roadblock. This takes us back to the analogy where the Indian movie analogy where the villain entered the movie, right? Unfortunately, we had issues which we had to fight through. These are a few of the issues that we identified which stopped us on our tracks. One, we had increased deployment times. As the size of the stack increased, the Docker swarm increased, the deployment times increased. And it got to a point it was truly unacceptable. And we also started seeing duplicate IP issues, right? There were times where more than one container was coming up with the same IP, which was scary. So to stop that, we had to completely, stop all the parallel deployments and serialize all the service deployments. And we also noticed connectivity loss. There were times where, in a random manner, there was packet loss between two services. This was the scariest of all the issues that we listed here. The reason is we had 30 services, and just thinking this connectivity loss spreading across all 30 services is scary, right? It would have caused a major outage. All in all, it stopped us. We were facing scalability issues, and there were other service teams which were working to build these services, and they wanted to onboard, but we couldn't. So we had to come up with technical issues. Cool. So we had to come up with a quick solve, to mitigate these open issues, and also come up with a permanent solution for us to continue onboarding the rest of the services.
So, as Shrikant mentioned, we face these issues. So we have to do two ways. We have to stabilize our platform and then actually solve it so that we can actually continue with our journey. So one of the first things we did is that we went back to our business teams to reprioritize their plans so that we can slow down the onboarding process, because one of the trigger points of the issues we saw was when we started doing multiple services or scaling up a particular set of service, or when there is this increase in scale of containers, that's when we started seeing the issues. So we slowed down the onboarding process. And other thing we noticed is that because of the scale, we tried to split up our Docker clusters into at least two clusters, one for the front-end service and one for the back-end services. That way, we could reduce the size of individual clusters into a more manageable number of containers, and that reduced our deployment time, and so that we can do parallel deployments into two different clusters. We also noticed that one of the places where we are getting restricted is the scaling of our key value store that was storing the cluster information. So since we had automation in place and we were in the cloud, we could quickly change the machine types and give it more resources, and that reduced our deployment time and stabilized the platform a little bit. While all these things were going on, we heard about and we saw all the major improvement Docker was making in the Docker offering, and we are very excited to use that. And we are doing some POCs to see how we can fit into our architecture. But when we noticed these issues, we accelerated our upgrade plan. We decided that we have to go to the newer version of Docker in order to address these issues?
So like Sanjay stated, we started working on the upgrade plan. This time we decided to go with Docker Enterprise Edition, and the latest and the greatest version at that time was 1703. We realized that it would be, Docker would be a good strategic partner to have on our side. So we started working with Docker to have the software procured while we were doing the POC. And we launched a week after we signed the paperwork. And right after we launched, we noticed that most of the issues getting resolved. The deployments were back to normal. The duplicate IP issue was resolved. And all in all, it enabled us to scale up and add more services. So as a part of the POC, we made sure this time to scale up the cluster to 4 times our needs and make sure that it performs. And it did. So we make sure that it was successful before we signed the deal with Docker. So it not only solved all the open issues that we had, it came with some new features that we were more than happy to leverage. One of them was self-healing. Earlier when a container went down, it was a big event. We used to get paged. Now even before the alert gets fired, we have a container up and running. So that's great. And also it supported IPsec out of the box. So it enabled us to meet our security needs without much effort from our end. So to our current state, we came a long way. We started with a monolithic stack running on our data center. So we started building an open source based cloud container platform. And in close to 2 years, we were able to migrate the entire e-commerce business to this new platform. So we built a cloud native platform. We built the services ground up again using the new development frameworks. Today we have all the way from JCPenney homepage to checkout all the services running on the new platform. We have over 120 plus microservices. We do over 100K deployments. We run a multi-billion-dollar business on this new platform. One of the big wins that we wanted to call out was 2017 peak. That's the holiday season. We ran on this new platform, and it ran with 0 issues. That resonated across our entire enterprise. Now we have different business units who are working with us to onboard their services to the new cloud platform. Lately, we collaborated with our store service, and we onboarded a couple of services, and it went live a couple of weeks ago, right? And we are in works to onboard more services to this platform and continue this journey.
So, in order to, as Shrikant mentioned, that we had 120 odd services right now, and we have a geographically distributed team. So we had to adopt some very simple process in order to let the service teams go from creating a service, thinking about a service, and going into production. So like most of the other organizations we have been interacting with here, we had a very simple process from the application development community. Once they check in a source code in the repository, we have a standard Jenkins that builds the image, does all the static analysis, and uploads to our registry. And at the heart of our deployment process is basically some services that we wrote on top of the Docker API, which is called our Docker Deployment API. And so the Jenkins process, the deployment process is triggered to Jenkins, and it interacts with our Docker API and this deployment API to deploy into a particular environment. We open this one up to the development teams so that they manage deployments under the lower environment, and the operations teams use the same thing to deploy into production environment. And the entire process is visible to all the stakeholders via a dashboard which the DevOps teams created, and Shrikant is going to give some glimpse of it. So the entire process is streamlined from when they come in, create their own repository in our Git repository, and then the entire process is automated up to their build and deployment pipeline. So here is a simple example of some of the artifacts that the development team, in collaboration with the operations team, and they create in their own repositories. When we initially started, it was a Jenkins pipeline job before we sort of migrated the entire pipeline into under an API. So we had a Jenkins library that we maintain, our team maintains and enhances, and they just refer to, the application team just refers to this library, and they set up the base name of the services and maybe some environment default sections, as you see. And we use these parameters into a stack, into another stack file, where we have enhanced the stack file with placeholders. And these are the configurations that is sort of jointly managed by our operations team and the development team. So based on the environment, we go to a config repository, we pull in certain parameters. As for example, here you are seeing that limits, the memory limits for a particular environment, or for example, the services version. So we have one specification, a deployment specification, and then based on the service version, based on which environment it is going to, we replace the values and then finally invoke the Swarm API to deploy the service. And every team has exactly the same specification, the same way they write the specification, and the cloud operations teams, they just use it to deploy it into production. And they use it to deploy into their non-prod environments. So this allows us to collaborate very effectively between the operations team and the application development team. And that way, we are sure that it is the same specification that is run in lower environment as it is being running in production.
Now a brief demo. So this is the DevOps dashboard that Sanjay was referring to earlier. As you can see, we have 2 clusters running in production, that is Prod 3 and Prod 4. At this time, Prod 3 is taking 100% of traffic, and we have about 130 services, which are hosted on close to 500 plus containers. And we have 2 clusters. We can balance the traffic, or we can have some percentage of traffic go to the other cluster. And there are other services on this homepage, like which we had to block due to legal reasons. We have a microservices grid view, which enables the dev teams to go check what services are running, what versions are running, and also be able to see if there are any issues and if they are balanced properly, or who deployed the latest version. All that data is captured here. We host on AWS, so we do a chargeback model where we capture, at a service level, what's the consumption is and how much they're paying in a monthly manner. And this gets updated daily, so the dev teams can go in and see what their usage trends are like. And traffic, this gives a glimpse of JCPenney, the user traffic, and also any anomalies are called out, so the operations team and the dev teams can dig in and see what's happening in real time in our website. And also we have continuous integration where we publish the build metrics and also the pipelines that are running. And in the build metrics, you can see what are the builds that are currently running and who are the top build breakers, all that information that the dev teams need. Also the quality metrics, we publish a quality dashboard at an enterprise level and also at a project level where you can dig in and find out what's the quality of your project like. DevOps tools, it's just links to a bunch of developer tools, like any new developer gets onboarded, they can just go ahead here and click and figure out where the tools are and how to download them and how to configure them, and the documentation along with that. So one of the major things that we identified when we moved to the microservices was monitoring. Monitoring and the support aspects are harder in the microservices world than in a monolith. Right now we have 100 plus services. There are more points where we can break. So we wanted to come up with a single pane of glass where we can have the entire ecosystem monitored and also have an ability to have issues and alerts pop up on that screen. So this is what we came up with. As you could see, we have 100% of our traffic flowing through Prod 3. That's the cluster. You have the other cluster at 0%. We can balance the traffic. We have currently the error rate is about 0.08, and you can see the requests per second. And now you can dig in and see what's happening at the service level, right? You can see the traffic coming through internet, through our edge, and then how it's flowing through all the services. So it's not only traffic that is captured at the real time, it's color coded as well, right? You can see if there is an error, it'll be red, and if there is a warning, it's going to be yellow. You can see this is yellow and there is a warning. Now the support team can go click at this and see what's happening, right? Yeah, there are too many 400s, so they can dig in and figure out why this is happening. And also you can set warnings based on your error buckets as well as your response times. And we continue to update this, based on the feedback from our dev community. So we have come a long way. These are some of the highlights we wanted to call out. We were able to migrate a multi-billion-dollar business to cloud containers and open source based platform in less than 2 years. We are running more than 120 plus microservices containerized in cloud. We do over 100K deployments, and we had a zero downtime peak in 2017. Zero issue peak in 2017, and it was running on this new platform. We came a long way from the big bang releases that we were doing earlier. Today we release in an on-demand manner. We let the service teams deploy at their own cadence. We do releases daily and and on-demand, like during the day as well. And we were able to leverage the power of cloud by implementing dynamic scaling. We know, during the holidays, during the weekends, we receive more traffic than the normal days. So we scale up our stack to meet those, to meet the demand for those big days and scale down. This enables us to reduce the cost and also use in a more efficient manner. All in all, we were able to accomplish our goal. We were able to improve the time to market. Now we are able to release more features and also in an iterative manner where we can capture the customer feedback as early as possible and as many times as possible.
So in this sort of 2-year-old journey, we made some decisions at the beginning that helped us, and there are some things that we learned as we continued on the journey based on the challenges that we faced. And there are a couple of key takeaways. First thing is that we were actually doing a large-scale transformation from a monolith architecture, deployment in the data center, to a new microservice-based architecture, deployment in the cloud with a new software stack. So it is an enormous risk that when we started this journey. So our goal was to reduce the risk as much as possible. So we had to do this controlled onboarding of services. That was important initially to prove out that the platform works. When we ran into issues, we went back into that control so that we can get that leeway and the runway to actually put the fix in place. So trying to, when we did the service migrations, our actual website was still up and running. So we couldn't stop the business even for a day to do this migration. So everything was done, the surgery was being done while the patient is still alive. So we had to control the onboarding of services. One thing that helped is our multi-cluster design. So when we did the Docker upgrade, we actually spun up a new cluster with a new version of Docker, tested it with a small amount of traffic, make sure it works, and before we moved the traffic through. So the multi-cluster design allowed us to reduce our risk further. The second thing is that we emphasized on the application teams that to develop their services in a cloud agnostic manner using Docker so that they can package all their dependencies into a single deployable unit. And making it cloud agnostic allowed them to actually take the same container. If there is a problem in production, they can download exactly the same image on their laptop and see what's going on. So it was very important for us for developer productivity and quick turnaround of fixing bugs in production. And second thing is since we use Docker and the dependencies were already packaged, we could upgrade our infrastructure in a seamless fashion without actually impacting the application team. So we managed to upgrade Docker versions, again, go into a different cluster, take the same container and run it. So the Docker gives us the ability to do a sort of frictionless upgrade of the underlying platform. We couldn't have done this whole journey without the big support from the leadership team. They were the ones who set up the vision and empowered these individual teams to make decisions to achieve their goal. And they were always there to help us to make the decisions. Sometimes we go back to them and say, hey, we need to maybe change it a little bit, change our roadmap a little bit in order to address problems. And they were very sympathetic towards that and made sure that we get all the support that we need. And they also managed to break down the walls between the development team and the operations team so we could all come together as a single unit to achieve our goal. And that was very helpful, and it was very empowering to the team. Now they were responsible for the outcome, and they are given all the tools to achieve it. So the leadership support was very crucial for our entire journey. And second thing, in terms of empowerment, we always try to create the tools so that the development teams are empowered are in charge of their service right from there when they start the first line of coding up to production and monitoring it and maintaining it. So our main emphasis has been to create tools to empower our development teams as well. And since it was a new platform, we had to spend time in training people on usage of this platform, on usage on Docker, and then the teams themselves, they started influencing and training other teams, and that's the only way we could scale. And it was important for us so that all of them follow the same platform principles and make sure that their application can go into production as soon as possible. And finally, we moved from monolith. That's where we have been developing our applications for all these years and go into a fairly big distributed system. And so we had to teach people how to think about fault, how to isolate their fault so that fault in one service doesn't go out and make an entire site, doesn't cause an outage across the entire site. So we had to work with the business team. It's not only a technical challenge, it is also a business challenge because we have to come up with ways in which a customer may have a degraded experience, but it's not like they cannot do their function. So this fault isolation and training people to think about that faults will happen when you are in the cloud, when you are running microservices, and training our business as well as our application team to think about those right when they are thinking about designing their application was also very crucial for us. Finally, we couldn't have done this journey without a great team, great talent that we managed to attract, with the help of our awesome HR team. And it was the people that made it happen, apart from the technology. And they are the main heroes in this.
So yeah, so we continue to hire. This is a plug for hiring. So we continue to hire. We have more openings. Dallas is cheap and no state tax. So if you all are interested, please hit us up. We would love to have you on our board, on our team. There are multiple positions, in different business groups as well. So whatever is your interest, and we continue to innovate, right? As you could see, we were able to adopt open source technologies, and we would like to learn from the community and also listen to any new ideas. So this is the picture is taken right after Cyber Monday. We had, the week was the biggest week in JCPenney history in terms of customer volume as well as revenue, and it was run on the new cloud containers and open source based platform. So it was, the great work, coming through and then delivering what we started off with. At the same time, it was very relaxing as well that it all panned out well. So it called for a drink, so we went out, we celebrated. This is the team based out of Dallas. We have global teams, we have team in India as well. And then we continue to hire. Any questions?
I have a mic, so I'll just walk over to you.
Hi, thanks for the interesting talk. I just want to understand, were your containers mostly stateless, except for the logs, or can you talk more on that side?
So the services that you saw, which are in the container, they're all stateless services. Okay. Persistence, we didn't put Dockerization on our persistence layer. They were running on bare VMs. Okay, so most of the storage aspect is from the cloud, some other cloud solution. Yes. I mean, the only thing that these guys, in terms of state, is the log files that get aggregated separately. Okay, thank you.
There's a gentleman here. There you are.
Hi. How many people did you have to train up initially, and for how long did you have to give them training?
So initially, we identified two services, right? One browse service and one transactional service as a part of the POC. So it started off with 5 engineers as one small lean team, and they started building out these services. Mostly the backend was all in Spring Cloud, and there was an architect. So I would say a team of 6, and they launched this service, and we had brown bag sessions where the developers talked to the other developers, and slowly we decided and came up with a roadmap. So it started off to answer the question about 6.
What kind of experience did the solution architect need coming in?
So this is it. One is an open mind, right? We needed a solutions architect who has who is exploring the open source technologies, who is who wants to innovate and also be able to take some risks. Docker, when we started, like there were others who are already doing this. Like Netflix has done microservices architecture way before we even started, and then we have other multiple companies which have done this before. So it's about the solutions in terms of we didn't have anybody who has done this before. To answer your question, it's mostly like we had a positive energy on the team, and we said like, yes, we can do it, and we put a timeline, and then we started working towards it. So it's mostly like basic Java experience, like who have done it before, and then who are open and innovate and be able to take risks. That's what we're looking for. Yeah.
I want to applaud your efforts. I haven't been to JCPenney stores in like 10 years, and it might be the case with a lot of people, but very recently I noticed that you were carrying the men's line, the polos, and I noticed how peppy the site was, and I became your customer again, and it's really amazing. And I didn't realize that you moved to microservices. So my quick question was, from the previous e-commerce platform, was that something like ATG or something like that? Or something that's commercial, or was it more like Magento, which was open source?
It is a commercial platform. I don't know if I'm allowed to disclose that, what platform it is, but yeah, you're on the right track, I would say. Yeah.
Hi, I was curious, like, how does the auto scaling work? Like, are those defined rules, or is it based on real-time traffic analysis?
Right. So we haven't implemented auto scaling because, as I said, our traffic patterns are pretty predictable in terms of we know which promotions are coming. So we scale it out prior to the events, but we take advantage of Docker scaling. Swarm Manager, you can easily scale up the containers. So we maintain the capacity. We already have decalculated how much capacity we need. So that is a work in progress. We are planning to implement that.
So it's the business need, right? For our business is very predictable. We know like X amount of hits are expected this day. This is the revenue expected. So, and then we know like on a Saturday and a Sunday we do more than Wednesday, right? So the need was to be able to scale up to meet that need, to meet the number that we already know, and. I mean, based on for our business, there is really no sudden spike unless we decide to throw a marketing coupon or we do an email blast. So we control our customer traffic to an extent. So auto scaling is not a real need for us, but when needed, we will definitely want to go ahead and invest on that. But right now, it's basic dynamic scaling. We know what we need to scale up and scale down. We put memory limits on all the containers, so it's easy for us to do the capacity planning.
Thank you so much.
Thank you.